Hi everyone. So in today's video, I will be discussing the main ideas of this stoichiometry lab. In this lab, you are studying reactions to overall, hopefully better understand stoichiometry and to learn more about determining limiting reactants, excess reactants, theoretical yield, all which are related to stoichiometry. So, what is stoichiometry? I know it's a strange word. Sometimes when you type it in, it doesn't even get recognized on Word. And it's a long word, and it can be overwhelming. All it really is it has to do with the ratios that you have in chemical reactions. So here, for example, we have two chemical reactions. Both of them include sodium bicarbonate and hydrochloric acid, but one of them actually involves two HCl formula units in this case, versus the other one only involves one. So you can see there's a different ratio here. And the way you can relate that to something in real life is think about just recipes, just some sort of cookie recipe. Let's say you have a sugar cookie recipe and another recipe you have is a snickerdoodle. Both of those, based on their texture, based on your own liking, you know, it could be the same type of cookie, but just from person to person, you have different likings of, I like my cookie to be more fluffy versus I like it to be more, less fluffy. However you like your cookies. There's different ratios, and those different ratios call for, overall different recipes. So that's what you can think of stoichiometry as. They're like recipes, and specifically the coefficients are what tell you the recipe values, right? So that is the main idea in this entire lab. You are going to be doing a bunch of calculations related to stoichiometry. So I will let you read through the intro. It discusses, limiting reactant, excess reactant, all that. Here's an actual example, a visual example, where you can see that you have H2 and Cl2 reacting to form HCl. But notice that you end up having those H2 little tiny molecules left over. So that would be your excess, right? And that would mean that your Cl2 is your limiting. So I explained that a little bit more here in this paragraph, so I'll let you take a look at that. And then I have actually the steps outlined to calculate theoretical yield, so that's definitely super useful. And then finally we end with discussing the calculation for percent yield. So in this lab, you are heading over to this PhET virtual lab. So I've gone and opened that up already, but I do want to point this out to you first. So there's a part 1, sandwich stoichiometry, and I know that's kind of funny, but you'll see why it's sandwich stoichiometry. I was like debating calling this lab sandwich stoichiometry, but I was like, let me just call it stoichiometry. So sandwich stoichiometry for part 1, and then molecules. Okay, so that makes more sense, right? In chemistry class. So you have two major parts to this data collection. Okay, so now I'm going to head over. I already opened up the PhET link that I had there. So you can see their sandwiches versus molecules. So for the sandwiches, I just clicked it, and unfortunately my screen is a little bit limited right now. You can't see the entire screen that you will see, but this is essentially how it looks. And what you're going to do is follow the different recipes that I gave you, or the different amounts that I gave you, and you have to see how much how many sandwiches you made, and then how many are left over. So this is a really good virtual and visual representation of understanding limiting reactant and excess reactant. So you're going to record your results in part 4, data collection. And you will do the same thing for all these different situations. So first just bread and cheese, and then bread, meat, and cheese, and then bread, meat, cheese, but you are customizing your own recipe. You want your sandwiches to have 2 breads, 3 meats, 2 cheeses. So very specific, okay? So you change the recipe up basically a little bit. Again, you're going to record the data. For the molecules, you will go here. You can toggle between sandwiches and molecules down here. You can also play this game. And yeah, unfortunately, I have the screen limited to like what I'm recording right now, so it's not showing you everything. But once you begin to use it, it'll start making sense. You can tell it what to do. It can make ammonia. It can combust methane. So there's different options here of what you're doing. Basically, yeah, it's very similar to the sandwich, except now you're working with actual molecules. So, in addition to reacting these and recording how many leftovers, how many you made, you are going to determine the balanced chemical equation, and you are going to pick one of the 4 scenarios and show all your calculations for determining that limiting reactant. You're going to do the same thing for ammonia and then for methane. And that, again, I was toggling between those options at the top right hand corner, and then to toggle up here. And like I said, I know you can't see it, but it's showing it up here. And then to toggle between sandwiches and molecules is down here in the center. So that is your data collection. Here are the actual tables where you're writing everything down. How many total sandwiches, how many leftover breads, how many leftover meats, leftover cheeses. For some of these situations, I think it was meats did not apply, like we weren't using meats to make the sandwiches, so just leave that blank or cross it through, whatever you want to do. And then for the rest that do include meat, just make sure to record that. And then here for part 2, it's kind of, the tables are more split up. So first we have the water production, how many H2O you produce, how many leftover O2, and you pretty much get the point. And then you're going to write down the balanced equation, calculations to determine limiting reactant, production of ammonia. So it's the same idea for all of these.
So for the applied exercises, you will be opening up this video on YouTube, of course, which I actually already have opened. It should look like this once you reach, watching the middle. You can stop watching around 3:23, so I'm actually going to add that in here to the procedure. I might as well. So watch it from the beginning, watch until minute 3:23. You don't need to watch anything else after that. But what is going on here is that this, I think maybe Anne is a professor or a teacher, but Anne is reacting magnesium and hydrochloric acid, so Mg and HCl. So they go through first the setup on how they completed this. They actually measure how much in mass, how much magnesium they added, and then they also detail how much HCl will be reacted with the magnesium. So what you're going to do is record that in table 5. So there's a certain amount of magnesium added into the yellow balloon. So that's what these colors refer to. They refer to the balloons. And then a certain amount for green, blue, purple, all which you can see in the video. So I'm going to let you record that. And then you are also going to record the amount of HCl used for each trial, as well as the molarity of that HCl used. Before you start, just make sure to balance this equation. And then from there, from these measurements that you record, you will complete these calculations. So you're going to calculate how many moles of Mg were used for each trial. So there should be 4 instances of you calculating out the moles of Mg. And then here you're going to calculate how many moles of HCl were used for each trial. For HCl, you actually only have to do it once because you use the same volume and molarity, so that's a big hint. You use the same volume and molarity for all 4 trials. And then you will determine the limiting reactant. So I'm actually going to leave some more space for you here because this may be a little bit more time consuming and take more space, but I would like you to show all the calculations, units, all the dimensional analysis, that entire setup. And then just some follow-up questions where you discuss limiting reactant, why there was leftover magnesium, and you will answer these. I'm going to add in a little instruction here where I would just like for you to answer these in full sentences, complete sentences. Up here, it's all calculation, so I'll add that in as well. So that is everything for the applied exercises of this lab. As always, if you have any questions, just please let me know.